Hello students, I am Ms. Diksha Gaonkar, Assistant Professor in Botany from Government College of Arts, Science and Commerce, Kepe. Coming to program, Bachelor of Science 3rd year, Subject Botany, Semester 5, Course Code BOC 106, Course Title Cell Biology and Plant Biochemistry. Title of the unit Biomolecules, Module name Structure and the properties of monosaccharides, glucose and fructose. Outline, Introduction of carbohydrates. We are also going to learn about types of monosaccharides, structure and properties of glucose and fructose. Learning outcomes. At the end of the module, you are going to learn about or define carbohydrates, monosaccharides, classify the types of monosaccharides, list the properties of glucose and fructose, draws the structure of glucose and fructose. Coming to the introduction, monosaccharide comes from the Greek words. So, monos in Greek means single and saccharide means the sugar. They are the most basic units of carbohydrates. With a few exceptions, for example, in case of deoxyribose, the monosaccharides have the chemical formula CXH2O n number of times. Coming to the properties of monosaccharides. So the most important monosaccharide is glucose and it comes under hexose. They are the simple sugars and are usually colorless, water-soluble and crystalline solids. Some monosaccharides have sweet taste. Monosaccharides are the building blocks of disaccharides, for example, sucrose, lactose, and polysaccharides such as cellulose, starch, etc. Each carbon atom that supports the hydroxyl group is a chiral. So, all the carbons except for the first and the terminal giving rise to the number of isomeric forms, all with the same chemical formula. For instance, glucose and galactose are both the aldohexoses but have a different physical structures and the chemical properties. Carbohydrates can be represented in the linear or the cyclic form. The cyclic form is formed either with the 5-carbon or the 6-carbon ring. So here is the diagram which shows how the furanose, that is the 5-carbon ring, is represented. Whereas this is the second diagram of the pyranose ring, for example the glucose, which shows the 6-carbon ring. Coming to the types of monosaccharides. So let us see which are the different types. So basically depending upon how many carbons are present, that is the number of carbons, the monosaccharides are of different types. So if 3 carbons are present, it is triose. If 4 carbons are present, it is tetrose. If 5 carbons are present, it is pentose. 6 carbons hexose. 7 carbons heptose. And these are the respective examples. Glyceraldehyde, erythrose, ribose. Then under 6 carbon hexoses, we have glucose, fructose and galactose. And this is pseudoheptulose. Coming to the properties of glucose. Chemical name of glucose is again glucose. Chemical formula C6H12O6. So 6 carbons, 12 hydrogens and 6 oxygens we have in this. Density, it is 1.54 grams per centimeter cube. Molecular weight is 180.16 grams per mole. Melting point 146 degrees centigrade and taste is sweet of the glucose. Now, let us see the structure of the glucose. Now, when I say structure of the glucose, it can be represented in different forms. As you can see on this slide, the first diagram, it shows the chain form of the glucose. The second one is the ring form of the glucose. So, here you can see the carbon 1, 2, 3, 4, 5, 6. They are represented in the form of a chain. So this is a chain form of glucose, whereas this is a ring form or the cyclic form of the glucose, wherein you can see the different carbons 1, 2, 3, 4, 5, 6. They are represented in the form of ring. So let us see. Now, when I say the structure, when I see this open chain structure of the glucose or open chain structure of any biomolecule, it has got certain limitations. So let us see now the open chain structure of glucose. It could not explain the following facts or the reactions. Okay, let us see which are the ones. So the first one, in spite of having aldehyde group, it does not give results for certain tests such as Schiff's test. Okay, and it doesn't form hydrogen sulfate in addition product with the NaHSO3, sodium sulfate. Then we have the pentaacetate of glucose doesn't react with NH2OH, indicating the absence of free CHO group. And the third one, glucose is found to exist in two different crystalline forms, alpha and the beta. So these are the three things which cannot be explained with the chain structure of the glucose. So the alpha form of glucose, in case of cyclic, it is obtained by the crystallization of concentrated solution of glucose at 303 Kelvin. The beta form of glucose, again the cyclic form, is obtained by the crystallization from hot and saturated aqueous solution at 371 Kelvin. And these are the cyclic form or the ring form or the Howard structure of the glucose. So the only difference between the alpha glucose and the beta glucose is that, as you can see here, carbon number 1, carbon number 2, carbon number 3, 4, 5 and 6. The only difference that you will see in the arrangement is the presence of this OH group. In case of alpha, it is present below, and in case of beta, you see this OH group is represented here up, whereas here it is present down. This is the only difference between the cyclic form, the alpha glucose and the beta glucose. Coming to the second one, the example under monosaccharide, the properties of fructose. So we have the chemical name fructose, chemical formula C6H12O6. Now if you look at the chemical formula of the glucose and fructose, it is same. The number of carbon 6, number of hydrogens here it is 12, and number of oxygen again it is 6. Coming to the solubility. Solubility, they are soluble in water. Fructose is soluble in water. Molecular weight 180.156 grams per mole. Melting point 103 degrees centigrade, and taste is again sweet. Let us learn some more properties. Fructose is important ketohexose. That means the ketone group is present, which is obtained by the hydrolysis of disaccharide sugars. It is white crystalline solid at room temperature, and it is odorless sugars. It absorbs moisture quickly and it becomes sticky. Sucrose can be fermented anaerobically by yeast and bacteria. And yeast converts sugar to ethanol and carbon dioxide. Coming to the open chain structure of the fructose. So as you can see here, the number of carbons 1, 2, 3, 4, 5 and 6. So this is the open chain structure of the fructose. Coming to the cyclic form of the fructose, cyclic structure basically. So you can see here, this is alpha fructose and this is beta fructose. Now only difference is here the positioning of the OH group. Remaining all the structure is same in case of alpha and the beta fructose. So the ring formed is 5 carbon ring and it is named as furanose with analogy to the compound furan. In the free state, fructose is present in pyranose ring form, and in the combined state, it is present in the furanose form. So here is the diagram. So this is the chain form, and here you can see the alpha fructofuran nose ring. So this is 1, 2, 6, basically 5-membered ring here, 5 carbon ring, and here this is alpha D fructopyranose, 6-membered. See, you can see here 6 carbon ring. Okay, so this is furanose, 5 carbon, this is 6 carbon ring. Summary. So we have learned about monosaccharides, different types of monosaccharides, properties of monosaccharides, of glucose and fructose, basically structure of glucose and fructose. These are some of the references. Thank you.